Okay, in this lesson we're going to look at direct variation. We're going to elaborate more on this in class, but I wanted to get you started on identifying direct variation. First of all, what is direct variation? Direct variation is a situation where two quantities increase or decrease, at the same rate. So there is a constant rate of change that we are looking at. Some important things to know about direct variation is direct variation is also considered proportional. So you may be a little bit familiar with proportionality, so that's going to help. We should know that when things are proportional, that means that their y-intercept is 0. So it's the same thing with a direct variation equation. The y-intercept is going to equal 0, which means, if we look at it graphically, which means the graph goes through the origin. Okay, so some things to look at. So now we're going to look at some more aspects of direct variation. So if we're increasing and decreasing at the same rate, we have something that's constant. When we look at direct variation, we call that constant k. And that constant k can simply be written as y over x. That may look familiar. It's similar to slope. Basically, this is called the constant of proportionality. Or sometimes you see it called the constant of variation. Okay, which is basically the slope. The constant of variation, the constant of proportionality is the slope. And we know when we're comparing slope that our change in y always goes over our change in x. The difference with direct variation is that it has this special ratio of y over x. You don't have to do subtracting because you know if it's direct variation, every y value over its corresponding x value will be the same ratio. The equation looks like this. Y equals kx. Notice there's nothing added or subtracted on. That's because our y-intercept is 0. An example of a direct variation equation could look like this. Y equals 5x. Simple enough, right? We also could have an equation, let's say 2x plus 3y equals 0. Now, that doesn't even remotely look like direct variation about the formula or the form that I just gave you. Right now, this equation is in standard form. But if I take it and I rearrange it into slope-intercept form, because that's what this form is, I would get 3y equals negative 2x, and then if I divide by 3, I see that that equation is y equals negative 2/3 x. And so then that is direct variation. The y-intercept is 0. That means it's going to go through the origin, and so it is direct variation. Let's look at the table and the graph below. Let's just start with the graph real quick. So notice it's going through the origin. Right now this has a positive slope. But in our definition at the top, we said that the two quantities could also decrease at the same rate. So we could have a negative slope going through the origin, and that would be possible. Now, looking at the table, the way we tell from a table. So remember, our constant of variation has that special ratio. So if I take this point and I write y over x, negative 2 over negative 4, that gives me positive 1/2. Well, if this is direct variation, then every single ordered pair, except for the origin, not this one, is going to give me that same ratio. So this would be -1 over -2, which is still a half. And we would see that for every single one of these. So then, and I know and even if I didn't know, even if I didn't see the y-intercept on my table, if it has this special ratio, it is going to be direct variation. So if I, oops, I wrote that wrong. So if I wrote the equation, it would be y equals 1/2 x. That's it. Now, what I'm going to want you to do when you come to class is I'm going to give you a set of problems. Some are equations, some are verbal examples, some are tables. And I'm going to want you to sort these according to which ones represent direct variation and which ones do not. So you may want to take some time, organize these, write these down in your notes on which ones you think are direct variation and which ones you think are not, so that you can do the activity a little bit faster.